Okay, today we're going to be looking at linear and nonlinear functions. Okay, those are the two main classifications of functions. Okay, there's two things you need to know about linear functions. The first is they have a constant rate of change. And the second is that when you graph them, they are a straight line. Okay, now, linear function should sound familiar because that's what we spent all of Chapter 8 doing. Linear functions, lines. That's when we did slope-intercept form, y equals mx plus b, all of that stuff. All of those things are linear functions. Okay, because they have the same rate of change everywhere. The rise over run stays the same the entire line. That's what makes it a straight line. Okay, but now we're also going to learn how to recognize nonlinear functions. And as you can probably guess, that means that they do not have a constant rate of change. And if you were to graph them, they are not a straight line. Okay? So the main difference in linear and nonlinear is that linear functions are straight and nonlinear functions are not. Now there are a lot of different things that can cause a function to be nonlinear, and we'll look at those later in this video. Okay? But right now, you just need to understand what is linear and nonlinear. Linear means a constant rate of change. The rate of change is always the same. Okay? This constant rate of change is what makes the straight line. Okay? So if it has the constant rate of change, then it's going to be a straight line. And if it does not have a constant rate of change, then it's not going to be a straight line. And vice versa. Okay? So if you can see that the line is straight, then you automatically know it has a constant rate of change. Or you can see that the line is not straight, then you automatically know it does not have a constant rate of change because it's not changing the same everywhere. Okay, now, the first way that we will identify these is from a graph. Now, most of you can probably already figure out how we're going to identify them with a graph. Okay, it's just by using the second bullet point. Is it straight? Okay, when you look at the graph, is it a straight line? Okay, when you look at the graph, is it a straight line? Okay, so you should be able to write down whether these are linear or nonlinear. I'll give you a second to do that real quick. Okay, so looking at the first one, the blue line, that one is linear. And it's linear because it's a straight line. That means it has a constant rate of change. That's what makes it linear. Okay, and if you look at the red line, it is nonlinear because it is not a straight line. It curves this way and curves back up that way. It's not straight. So since it's not straight, that means it does not have a constant rate of change, which means it is nonlinear. Okay, now, this type of line, like this red line, is not the only thing that can be nonlinear. Okay, now a straight line is the only thing that can be linear. Okay, now, it doesn't have to be exactly in this position, but no matter where it is, it has to be straight. Okay, but for nonlinear, it could be any type of line. Okay, you could have a line going like this. That would be nonlinear because it's not straight, it's curving up this way. You could have a line like this. That would be nonlinear. Even though this part looks like it might be straight and this part looks like it might be straight as well, there's a turn in the middle of it. So it's not all the way straight. Okay, or you could even have something like this that just keeps going up and down. None of these are straight lines. Therefore, none of these lines are linear. Every single one of them is non-linear because it's not a straight line, which means it does not have a constant rate of change. Okay, now the second way that we will identify these functions is slightly harder than the other. Okay, the graphing way is easy. It's a straight line, it's not a straight line. Okay, but using an equation to be able to tell if it's a straight line is a little bit more difficult. Okay, but there are things you can look for. Okay, when you're looking at an equation, the technical definition of what makes it linear is if it can be written as y equals mx plus b. Okay? So if you can write it in slope-intercept form, because remember this is y equals mx plus b is the slope-intercept form. Well, if the equation is written in this form, then it must be a line because it has a slope, which means a constant rate of change, and a y-intercept. This is a line. So if you can write it like this, then it must be linear. Okay? But sometimes that's kind of difficult to really be like, well, how do I know if I can write it that way? Okay? So here are some things to look for to kind of help you along to know whether or not you can change, that you could write it as this without actually having to change it into it. Okay? So the first thing you need to know is that x and y, both variables, have to have a 1 as the exponent. The exponent has to be 1. Okay? If it's any other exponent, on the x or on the y, then it's not linear. Okay, so x and y have to have an exponent of 1. Okay? And the x and the y cannot be multiplied by each other. Okay? So, the two main things that you're looking for are, do x and y have an exponent of 1? Okay, and making sure that x and y are not multiplied together. So you don't have x times y anywhere. Okay, now, I'm also going to give you some things to look for that would automatically mean it's not linear. Okay, which means it breaks one of these two rules, basically. Okay, so the first one, x squared. Okay, or really x to any power other than 1. So if you see anything like this, an x squared or x to the third or x to the fifth, x to anything other than 1, then it's not a function. It's not linear. Okay, the next one, also the y. The y can't have any exponent other than 1 on it either. So again, not linear. Okay, can't have x times y. So you can't have xy anywhere in or yx. Okay, anything that means x times y. So that means it's nonlinear. Okay, now those three were the ones that are pretty straightforward because that's pretty much exactly what it says up here. Okay, now there are some more though. Okay, 1 over x. Okay, you can't have 1 over x Because if you think about it, we're still in the middle of exponents. What is the exponent on this x? It's a 1, right? But it's in the denominator. So what does that really mean it is? It really means it's x to the negative 1. So that's not an exponent of 1. So if you see an x in the denominator, nonlinear. Okay, and the same thing for the y. The y cannot be in the denominator either because that means it has an exponent of negative 1. So can't have that. Now this last one is going to sound a little weird, okay? Because it's something we hadn't really talked about yet. Okay? But if you see a square root of x or a square root of y, okay, this is actually an exponent as well. But it's an exponent that's a fraction. So in other words, it's not 1. So all you need to know is that if you see a square root of x or a square root of y, again, nonlinear. Okay? So this one usually is the most confusing to people. Okay, so I've broken it down. We have the basic definition, the main definition. Okay, it's linear if it can be written as this. Y equals mx plus b. Okay. Then I've told you what you've got to have in the equation. You've got to have x and y with an exponent of 1. Okay. And they can't be multiplied together. Okay. Now look down here at the bottom. If you had any of this, there is no way that you could make this equation out of it. Okay? If you've got an x squared, there's no way that you can move it around and end up with just an x. Okay? If you've got 1 over x, there's no way that you can get that x out without messing everything else up. Okay? So if you've got any of these, it's nonlinear. Okay, so now here's some for you to try. You just have to determine if these equations are linear or nonlinear. Okay, so here's 6 equations. And you need to state whether it's a linear equation or a nonlinear equation. And if it's nonlinear, identify which part of the equation causes it not to be linear. So try to say kind of what messed it up from being linear. Okay. So, if we're looking at number 1, number 1 says y equals 2x plus 1. Well, I don't see anything that's not supposed to be there, so that is going to be linear. In fact, if you look at this equation, it is literally in y equals mx plus b form already. So it's obviously a line. So it's linear. But also, if you notice, x and y have an exponent of 1, and x and y are not multiplied by each other. So it's linear. Okay, so now, when I look at number 2, it says y equals x squared plus 3. Well, I see an x squared. That's one of the things that I can't have if it's going to be linear. I can't have an exponent other than 1. So that makes number 2 nonlinear. Alright, when I look at number 3, it says xy equals 4. Well, that means x times y. Again, that's one of the things I can't have. I can't have x times y. They can't be multiplied by each other. So that causes this one to be nonlinear as well. Okay, number 4. It says y squared equals 4x minus 2. Well, I see a y squared. Can't have y squared. Can't have y with any other exponent other than 1, just like the x. So, number 4 is nonlinear. Alright. Then number 5, we have y equals 1 over x plus 5. Okay. Again, 1 over x is on that list of things I can't have, because if the x is in the denominator, then that exponent is really negative 1. So I can't have anything other than positive 1. So that makes this nonlinear. Oops, sorry about that. Alright, so the 1 over x made this one nonlinear. Okay, and also, if this had been a y down here, 1 over y, it would also be nonlinear. Okay, now looking at number 6, I have x plus y equals 8. Well, I don't see anything that was on the list of things I can't have. The x has an exponent of 1. The y has an exponent of 1. They're not multiplied together. Now, it's not written in slope-intercept form like it was in number 1. But if it doesn't have any of the things I can't have, then that means I could. And you could see that I could move this x over here, and then I would have slope-intercept form. So, number 6 is also linear. Okay, now, this is probably the most confusing way to identify linear or nonlinear. But if you remember the few things that a linear equation can't have, then really you're just looking to see if the equation has any of those things. The same things you just wrote down from the last slide. Now, the third way that we are going to identify them is from a table. Okay, so this time you're given a table. We've already done from the graph, we've done from the equation, and this time you're given the table. Now, remember, linear just means that it has a constant rate of change. So if the table has a constant rate of change, then it's linear. Okay, so now from chapter 8, you should remember how to find rate of change. All you have to do is make sure that that rate of change is constant, or figure out if it's not constant. Okay, so rate of change is just rise over run. It's just the slope. It's just, is the slope the same everywhere? So the y is changing up 2, and the x went up 1. And then the next y changes up 2, and the x changes plus 1. That's the same every time. See, it went up 2 over 1, up 2 over 1. That's a constant rate of change. That means that since the rate of change is constant, that this function is a linear function. Okay, now looking at this other table. Okay, from the first y to the second, it went up 4. From the first x to the second, it went up 1. Then from the second y to the third, it went up 8. And from the second x to the third, it still only went up 1. So it went up 4 over 1, then up 8 over 1. That's not the same. So that's not constant. Okay, so for this function, the rate of change was not constant. So this function is nonlinear. Okay, so to identify from a table, you have to find the rate of change across the whole table. Okay, you can't just find the rate of change for one or two set of points. You have to find the rate of change across the entire table and determine if that rate of change is constant. If it is, it's linear. If it's not, it's nonlinear. It's as simple as that. So it's all about, can you find the rate of change, and is it constant or not? Alright, so now here's something for you to try. You have to determine if these functions are linear or nonlinear. Okay, so you've got two different tables. You should start with rate of change. Okay, so let's look at the first one, the one on the left. Okay, I always start at the top, and I'm just finding rise over run. So from 5 to 9 is up 4, and from 2 to 4 is up 2. So that's up 4 over 2. Now I need to check the other one. From 9 to 13 is up 4, and from 4 to 6 is up 2. So that's up 4 over 2, up 4 over 2. That's the same. So this function is linear because it has a constant rate of change. Now looking at the one on the right, I'm going to do the same thing. From the 2 to the 5 is plus 3. From the 1 to the 3 is plus 2. So that means it's going to go up 3 and over 2. And then let's see what the next one does. From 5 to 9 is plus 4. And from 3 to 5 is plus 2. Okay, so it's going to go up 3 and over 2, and then up 4 and over 2. That's not the same. So it's not constant rate of change. So it's a nonlinear function. Now, I do want to look at this table with you real quick. Okay, I'll give you a second, and I want you to try to determine whether or not this is linear or nonlinear, and then we'll look at it together. Okay, so I'm going to do it the same way I did the last two. I'm going to start by checking my rate of change, rise over run, for all the points throughout the table. Okay, so from 3 to 7, that's plus 4. And from 1 to 2, that's plus 1. And then from 7 to 15, that's plus 8. And from 2 to 4, that's plus 2. Now, if you rush through this, you may have even stopped when you got 4 and 8 and said, oh, not the same. So nonlinear. Okay? Or you may have went all the way through and you still say up 4 over 1, up 8 over 2, that's not the same. But slow down and think about that. Okay? Because this is a linear function. Now, but these numbers are different, so how can it be a constant rate of change? Okay, well, let's actually look at the rate of change. Okay, it's rise over run, the change in y over the change in x. Okay, so we're looking at this 4 over the 1. So the rate of change between the first 2 points is 4 over 1. For the second 2 points is 8 and 2. So it's 8 over 2. Okay, and as you see, those two are equal because 4 over 1 is the same thing as 8 over 2. Because 8 divided by 2 is 4, 4 divided by 1 is 4. Okay, or if you simplified 8 over 2, it is 4 over 1. Okay, so even though these don't have the same numbers, they're still equivalent. Then this is still constant rate of change. Okay, as long as the rate of change are equal, then it makes it constant. So that's why this function is linear. So, by now, you should be able to identify whether a function is linear or nonlinear. And you can do it 3 different ways. You can do it from a graph, like this graph, or you should be able to tell from an equation, like this, or from a table, like this. Okay, so you should be able to look at any of these 3 things and be able to tell whether this is from a linear or a nonlinear function. So let's look at each one and determine which they are. Now the first one should be the easiest. The graph is the easiest. All you're doing is looking at the line and seeing if it's what? If it's straight. It's not straight. It's a curve. It curves up and down and back up again. Okay? It's not straight, so it's nonlinear. Okay, so now the equation. When you're looking at this equation, now I said the exponents had to be 1. Well, in this case, the exponent is actually the x. So that definitely makes this equation nonlinear. Because there's no way to write that equation in slope-intercept form. And then for the table, again, I look at the rate of change. This is plus 1. This is plus 2. That's plus 1. That's plus 2. Again, so I see it went up 1 over 2, up 1 over 2. That's the constant rate of change. So this one is linear. Okay, and that's exactly what you'll be asked to do on your homework, and what you should be able to do after watching this video.